First one is the transition from A to B. Right, so this is shown here. That is you were the patient at A last year, but this year you moved to B. So it's this number, the stock of people at A last year time, the probability to move to B. And the second one is the remaining people. Right, that you were the people at B last year, and this year you are still remaining at B.
There is no possible move from B to A.
Yes, yeah, no, because in this diagram there is no reverse directions that will move back. Yeah, yes, in some cases, in some papers, or in some diseases, there's a possibility that the treatment can move you back to A. And in that case, they have to multiply the system or multiply the probability to this back. Yes, but that's possible and we can do that on this. Yeah, in this one, it's just one direction. Okay. That either you remain at the same stage, or you collapse, or you have the worsened condition and move to the next stage. Yeah, and if you think about the case of cancer, this is the clear example. Like the case of cancer, that you can just remain at the same stage, or you have the worsened case that you move to the worsened stage. Okay, so in Excel, it's not difficult to do this because you just think the formula that I recommend you to start with the diagram first, because with the diagram you will have a clear understanding that for the patient at each, there are two possibilities that you become the patient at stage B. The first one is to move from A to B. So you have to multiply the previous year patients at A times the probability to move to B. And the second one is the case that you were here last year and still this year you still remain at B as well. So you take the number of B last year times the probability to remain here. And then for the formula in the case of C, now you can imagine that from this diagram there are three possibles, okay, or possible directions that move you at C. The first one is move from A to C. The second one is you were at B and now you transit or you move to C. And the last case is the case that you were remaining at the same stage. So there are three possibilities of the people who are at stage C. And the formula follows the diagrams. So the formula shows that you will see three parts in the formula. The first part is the move from A to C. The second part is move from B to C. And the last part is the people who remaining there, who last year they were here, and this year they still at the same stage. So when you build the Markov model on Excel, it's not difficult because you just follow the diagrams, and in each box or in this cell you just look at the diagram and see how people move to that box. Like this case that in the case of C there are three possibilities. The first one is the inflow from A to C. Second one is from B to C. And the last one is from the same state of people who remain at C. And now we have the formula for the last one, B, the last step of the depth. From the diagram we learned that there are three possibilities to move here. Okay, the first one is direct move from A to B, the value of the expenditures or the cost. So for the first set of information, we know total life, that is the sum of this column, and we know the total cost. So this is the cost and the benefit for the first case. With the first one is the non-dilutive. We have two drugs, and you will see that actually in the calculations, you will see this term in the cost calculation for the first case. So for the first case, indirect cost plus the cost of the drug. Okay. For the first case. So actually, when you sum this column, you get the cost, which is the summations of direct costs, indirect costs, and also the cost of the drug. In this case, in the case of the first drug. Okay. And then we do the new calculation, which is the case of the second drug. So the second drug will change our probabilities. So the difference that cost to the group of this patient is the new distribution of the patients. So you will see that in this case, if you compare this table to this table, you will see a difference. And the difference comes from the change of the probabilities to move from each state. To move from state A to B to B and C to B to C, C to D. And that caused by the change of using the new drugs. You will see the distribution here is different from the first one. And the cost of the distributions, the cost of the change is from this one, the RR, and RR is the change of the probability that caused by the new drug that changed the transitions or the probability of transitions. So you will see that most of calculations add this term to the computations because they change the probability. Okay, so this change or is adjust the probability to move from one state to others. And the value of this RR is in this box, so this shows the treatment effects. That when you introduce the drugs, it changes the probabilities, and the value of the changing probability is from this one. So this, in this calculation, it's just the new factors that change the probabilities. So you will see that most what changes is the introduction of the and still we repeat the same calculations that we have the sum of the year of life here in the first column that we sum the values to get the total number of life in each year. And the next calculation, which is the new term, is this one, the cost. So in the calculation of the cost, if you click on the formulas, you will see that it's the summations of the direct cost plus indirect cost plus the cost of the first drug and plus the cost of the second drugs. So this case is the case that we use the combinations of the first and the second drug. Because if you look at the summations of both, there is the summations of direct cost, indirect cost, and the cost of first drug and the cost of the second drug. And as we repeat the same calculations, we compute the sums of the costs, and then you get the total value, so it's done with all columns. And from this we can get the new values of the benefit and the cost. The benefit is the life years. So we have the value of the life years. And also this is the cost. The new cost which is from the new drugs. It's a combination of people drug and the new drugs. Okay, from this we have two sets of values, the cost and benefit of using just one drug. And the second one is the cost and the benefits of using two drugs. And the next step is to do the analysis. So the analysis is still the same, that we do the ISO, additional cost per additional benefit. Okay, so the calculation is the case that we compute the difference between cost and the difference between benefit. And then you can get the ISO, which is the values of the change in benefit per change in cost. And in this case, we have this ISO is about 6,276 hours. Let's compare the case of using one drug to the case of using two drugs. Yes, we have the cost and the benefit. Okay, from this one you can compute we have the benefits of the first drug is the 799.12, and the cost of this first drug is 6,000,000, this number, around 6.3 minutes for the first one. And if we use a combination of the drug, the new values of the benefit increase is become 893 or 74 for the benefit of using two drugs. And the cost also increase, which will be 7,257,000. Okay, so now we have the number of the cost and benefit of these two cases. And the next step to make a final decision, yes, you have to compare, or you have to compute the difference, the additional benefit per additional cost. And this is the colleagues. This is the unit of colleagues. So we can compute the additional cost per 1 unit of colleagues, and that would be the number for the comparison. So, like the case of the warnings from the decision trees, even though we have this ISO already, additional cost and additional benefit, to make the final recommendations to the government, you need to know the willingness to pay per one colleagues of that countries to make the final recommendations and compare with the number that we have here for the calculations. Okay, so the main part is this table, because the new drug change the probabilities or probability on these diagrams from the initial one, from the first diagram. So for the benefit of the drug is the changing probabilities, and the changing probability on the whole structures of the diagrams come up with these tables. And when you sum the whole table, you get the additional life year that can be extended for the new price. But this also includes the new cost that we have to compute the cost from this table, and you get the new total value of the cost. Okay. From now we have four numbers: cost benefit of the first one, and the cost benefit of using a combination of two ones. Yes, we can do comparisons. So now if someone talk about Markov, this is Markov analysis. Okay, don't be scared or be discouraged with the name of Markov itself. I hope this will give you the idea that it's actually not complicated to do. If you know the information, if you know the probabilities, you can build Markov model on Excel. If you know the structure of all stages and you know probability of each stage, you can build Markov model on Excel and you get the first table. And then yes, indeed, you can use that to analyze the cost and the benefit. So a lot of, I think most of the literatures right now use Markov techniques. If you search on the most of the papers on PubMed, they will use Markov to analyze the cost benefit. And let's go to this one first. Yes, I think this papers. This one from the bottom. This one, hepatitis B. Okay, this is a case of it's a paper that used Markov technique to analyze the cost benefit of the therapy of the hepatitis B. In the case of China. So if you look at the papers, you will see that yes, the papers start with the Markov. So the first part of the paper introduces the diagram that we use. So it depends on the disease. It depends on the symptoms. That in this case, the hepatitis B has these many stages, and you will see that there is a link or the connection that shows the transition from stage 1 to the other stage. And also they see the arrows or the direction that show the recursive direction, which means that the patient remain at the same stage. Okay. And then yes, the next step is to identify the probabilities. So you will see that in these papers, it's like the one that I showed you in the mornings. The first table has to identify the probabilities that they use in each part. And the probability is obtained from the secondary source. You have to preview a lot of papers to get probabilities numbers. And yes, it's shown. Yes. You will see that this is the list of the number of the link and the probability for this link or this link, and this show the reference paper that is the source of the probabilities. So it's like the case of decision trees. You have to show the source of the number of probability that you use, and yes, it's coming in the first papers, and we have to identify specifically the papers that we use. The next step, you can guess that the next step is the table that shows, yes, the benefit and the cost for each state. So this one shows the benefit and the cost, so probabilities. So it's still show the list of the source we obtain this value in the model. And yes, table 3 is the cost is about the cost in each stage, and it shows the source of the cost. So it lists the cost in each stage, and it also lists the source of the data, the reference paper that we use, and this the main source of the cost. And the last, the next table, yes, you will see is compute the result, the ISA or the benefit, okay, the cost benefit ratio per 1 unit of qualities. So you will see that this use the ISA as the unit of comparison, how much you have to pay to achieve one additional unit of qualities. That is calculation come up. And yes, you can have the diagram look like this method. The unit of additional qualities and the cost. Yeah, and the last one is the sensitivity analysis that we have to show the robustness of your results. So this one is called tornado graph. So it's actually the type of the sensitivity analysis that shows how the result sensitive to the change or the variations of your assumptions of the probability and the cost and the benefit. This one you can do it on Excel as well, but you need software that will automatically generate this chart. So it's not difficult to run and obtain the sensitivity analysis chart. There are two software on Excel that allow you to generate this chart. I hope you familiarize with this one. This is the additional unit of qualities per additional unit of cost. So this is the example of using Markov model. So it's like the one that we went through in the morning, that you can use decision trees to develop your paper and get published in the international journals and all the work based on secondary evidence. We have to collect the data from many papers and try to combine the data of probabilities, the data of the cost, and the data of the benefit from many papers, and include those information into one model, and then calculate the additional cost per additional benefit. And the last step is to do the sensitivity analysis. So this is the example. Let's look at the second one before we have uploaded. So this one might give you another examples. So we have the basic idea of these structures, that we have 4 stages, like step 1, step 2 is the progressive disease, and we have 2 stages of the death from other causes and the death from the disease. So this is not a complicated case. We have the initial stage here, and then people at this stage can have maybe accident or other disease that cause them to death, and also we have the case that we have progressive symptoms, and the progressive symptoms lead to the death. So we have the structure like this one, and from these structures we can build solids. can build the Markov model look like this, which is similar to the technique that we used at the beginning. And then this 1,000 people can be in 4 possibilities in the next year. The first possibility is that they still in the first set. The second one is the case that we have the progressive disease. The third one is the case that they has the death from other disease or maybe from the accidents. Sorry, from this disease. The last case is the case that they pass away with these other cases or maybe accidents. And when you sum up, you have the same number, which is the shape or show as an indicator show that you have the correct calculations. So actually you can just repeat the calculations. You just run this. So you can build the models, and the model will run until you get the combination that leads most people to the left. So if you go through the model and look at the last slide, it shows the case that most of the people already dead, either the first one or the second one. And in these calculations, we have to compare the case that there is no drug therapy, no treatment for this group of people. This is the normal or the usual possibilities for this group of people. And then we have the second set, which is the set that we try to introduce the new calculations, which is if you go to the next tab, this is the case that you introduce in the calculation. So this is the second case that we introduce in the and the graph will show the distribution of people in this diagram or in these simulations. And from this table, we can compute the life years, and we can compute the cost. And our job is to compare these two cases, the case of no drugs treatments, and the second case is the sheet that we need to do the drugs. And yes, the drugs share the probabilities, and the drugs also cause a higher cost of treatments. And what we need to know is that the end of the table, the summations of total life years that extended and the total cost. And one special features in this model is the case that we can do the sensitivity analysis, which means that the assumed probabilities, the assumed cost is not just one value, but we will randomize that values between that. We will recalculate these two tables many times, and we get many results, many sets of the results. And this can be done from the Markov, the simulations from the Visual Basic. So we have to unlock the code, we have to unlock these programs. So typically in Excel, when you include the Visual Basic and macro on Excel, computer will think that this might be a trick or a virus, so we have to allow the computer to activate or to run this. This click will generate the calculations. It will randomize the probabilities, and the randomization of the probabilities and the cost of the treatments depends on these given distributions. Okay, so you will rerun the model many times, and each time that you run the models, the value of probabilities, the values of the cost of the drugs will be randomized. The randomization is based on these given distributions.